In this video, we are going to learn more about conditional probability. We are talking about conditional probability when the probability of an event depends on another event that already occurred. The conditional probability is then the probability of an event occurring given that another event occurs. Let's check some examples. So, for example, given that it's raining, what is the probability of Barcelona winning? So, in this case, the probability of Barcelona winning depends on it's raining or not. I guess that Barcelona is winning more when it's not raining, or it can be possible as well that Barcelona is losing more when it's raining. So the probability of winning depends on the event raining or not. So let's check another example. Given that Leo explained Sisi the chapter about probability, what is the probability that Sisi gets more than 90% on the test? That Sisi gets more than 90% on the test. So getting more than 90% on the test is event A. And this depends on Leo explaining the chapter to Sisi or not. So Leo explains Sisi the chapter about probability is event B. So in this case, the probability that Sisi gets more than 90% on the test depends on that Leo explains the chapter to Sisi or not. So probably when Leo explains the chapter to Sisi, the chance or the likelihood of Sisi getting more than 90% is increasing. And when Leo doesn't explain the chapter to Sisi, then probably Sisi has a lower probability to get more than 90%. So the event A depends on event B. So in the first example, we could also talk about event A and event B. The probability of Barcelona winning, or just Barcelona winning, is event A. And raining is event B. Event A depends on event B. Okay? So let's continue with the theory now. Because event A depends on event B that occurred before, we call the probability that we are calculating here the conditional probability, and we have a special notation for that. So here, if A and B are events, then P, the probability of A slash B, we write it like this, is actually the probability of A occurring given that B has occurred. So B happened, and then you're finding the probability that A will happen, given that B already happened. Let's check some examples now. Let's go to example 13 in the book first. But before we go to example 13, I just want to say that to find the conditional probability, It's quite often useful to work with Venn diagrams, two-way tables, or two-dimensional grids. So Venn diagrams, two-way tables, or two-dimensional grids are useful for solving problems. Okay, let's go to example 30. In a group of 25 students, 15 like milk, 17 like iced coffee, 2 students like neither, and 9 students like both. So here it's appropriate to use the Venn diagram, for example. We use the capital letter for the ones who like milk, we see here, and for the ones who like iced coffee, we use the capital letter C. Okay. So here we have all of the students, 25. We write that down with capital letter U. And then we have the ones who like milk, capital letter M, and the ones who like iced coffee, capital letter C. And then we have 2 students like neither. So they don't like iced coffee, they don't like milk, so they should be here. So we have to write number 2 here. And then we have 9 students like both. So they like milk and iced coffee, so they should be here. And then we know that in total 15 students like milk. So this must be equal to 15. Let's call this A. So A plus 9 must be equal to 15. So A is equal to 15 minus 9, which is 6. So A is here, and that must be equal to 6. And we also know that 17 students like iced coffee. So this group must be equal to 17. Let's call this B, for example. So B plus 9 must be equal to 17, or B is equal to 8. So we have 8 students who only like iced coffee. And that's how we create the Venn diagram. So 6 plus 9, which is 15, plus 2 is 17, plus 8 is 25. And in total we have 25 students here. So let's go to the question then. Find the probability in A that the student likes milk. So the probability that the student like milk. So the probability of M. So that is like all the students, which is 25, divided by the students who like milk, which is 6 plus 9. It's the 15 here. So this is 15 over 25, which is equal to 3 over 5. And then in B, we have to find the probability that the student likes milk given that he or she likes iced coffee. So this is the conditional probability. So we have to find the probability that the student likes milk, so M, given that he or she likes iced coffee. So he or she likes iced coffee, and what is the probability if he or she likes iced coffee that he also likes milk? So this is the conditional probability. So in the denominator, we have the students who like iced coffee, because that is our total. Because we have to find here the conditional probability, we have to find the students who, the probability that the student like milks, given that he or she likes iced coffee. So here we have the students who like iced coffee, which is 9 plus 7, which is 17. So here, the iced coffee likers. And then here, the milk likers inside the iced coffee likers group, which is this one here only. Because only 9 of the 17 iced coffee likers likes milk. So the numerator must be 9, because only 9 of the iced coffee likers like milk. This 9 comes from there. And that is the probability that a student likes milk, given that he or she likes iced coffee. Okay. Let's go to example 14. So this is an example where we use the Venn diagram, and in example 14 we have to use the two-way table. So we have the table here. So a restaurant owner collected the following data from his customers one night. So during one night he collected all this information here. So you have to find the probability that a randomly selected customer spent at least $20 and B and C as well. But before we continue, let's just finish this two-way table. We've learned that before, so we add here a row total and we add here a column total as well. So we do 12 plus 31, which is 43, 17 plus 15, which is 32, 12 plus 17 plus 9, which is 38, 31 plus 15 plus 13, which is 59, and then 9 plus 13, which is 22, and then 43 plus 32 plus 22, or 38 plus 59. You can choose which one you do, and that must be equal to 97. So we added the totals in it, the table. Okay, and then let's check what they ask. Find the probability that a randomly selected customer spent at least $20. So the probability that the student spent at least $20. Okay, so we have in the denominator the number of students. So we have in total 97 students, and we have to put in the numerator the number of students who spent at least $20, and those ones you can find here, at least $20, which is the 59 that we have here. So that is what we will have here in the numerator, so the 59. And this is the probability that a randomly selected customer spent at least $20. Let's check B now. You have to find the probability that a randomly selected customer spent less than $20 given that they had their meal delivered. So the probability, so this is a conditional probability. We have to find the probability that a randomly selected customer spent less than $20, so spent less than $20 given that their meal was delivered. So this is the event that already happened, so delivered. So we have to put in the denominator the delivered meals, because that is our total in this case, and the delivered meals are 22 in total. So in total 22 meals are delivered. So from that 22 we have to find which ones so spent less than $20, and that is this row here, the first row, which is 9. 9 of the 22 delivered meals so spent less than $20. So 9 people spent less than $20, so it's 9 over 22. Let me put this like this, and that is the answer to this question. So for C, in C, we have to find the probability that a randomly selected customer dined in given that they spent less than $20. So the probability that he or she dined in given that he or she spent less than $20. So from the ones who spent less than $20, so from those ones here, so that there's the 38 we have to put in our denominator. So from the 38 that we have to find the ones who dined in. So the ones who dined in are those. So 12 of the 38 dined in. and that is equal to 12 over 38, or we can simplify that, that is 6 over 90. Okay, so for example 14, we used the two-way tables, and let's do example 15, where we have to use the two-dimensional grid, so that you have an example about all of the examples, types of examples. So here, a pair of dice is rolled given that at least one of the dice shows a 6. Find the probability that the sum of the rolls is equal to 10. To solve this, it's better to use a two-dimensional grid. Okay. So here you can put roll 1, and here you can put roll 2. And then 1, getting a 2, getting a 3, getting a 4, getting a 5, getting a 6, and here the same, getting a 1, and you continue like this, and then you get this table here, this two-dimensional grid. Okay, let's say that A is the event where the sum of the rolls is equal to 10. Sum of the rolls is 10. That is actually this part here. And let's say that B is the event that at least one of the dice shows 6. So that is this event here. Okay, so we have to find the probability of occurring event A given that B has occurred. And B is that at least one of the two dices shows 6. So we can show that on our two-dimensional grid, that is this, because here the second roll, the second dice shows 6, and here the first one. So we have in total 1, 2, 3, 4, 5, 6 plus 5, 11. And from this 11, only two options. In two options, the sum is equal to 10. Here, the first roll gives a 4, the second roll gives a 6. 4 plus 6 is 10. And also this one. We have a 4 and we have a 6, that is equal to 10. And those are the only options. So we have like two options. So the probability that the sum of the two of the rolls is equal to 10, given that at least one of the dice is that one of the dice shows a 6, is 2 over 11. So we get the 2 like this, and the 11, let me mark it in yellow, is like this.